Now let us see how to implement a class adapter. We will add a new project to this solution rather than modify this existing project. Now let us add all the files from the old project into the new one. I've added the files. Now we will make this as the starter project. Now before I implement the class adapter, there is one change that I would like to make in the accelerometer class. This will give us a good motivation of using the class adapter. What I want to do here is change the way these values are specified. So rather than hard coding the values here, we will add a function that will return these values. This will be a virtual function and it will return a pair. We'll call this function initialize. And let's implement this initialize function here. Now all I'm going to do in this function is just return the initializer values. So we'll return -10 and +10. Note that I'm using the braced init list here. So there is no need to use the name of the pair class here. And then we will use these values to initialize the distribution classes. That's it. We're done. There won't be any change in the output of the application. So if we build and run, you will see the same output. The output has not changed. It's still same. We want to use this accelerometer with our flight simulator game, but we know that it has an incompatible interface. So that's why we used the object adapter here in the previous example. Now, object adapter will also work fine here, but one thing that I want to do is, in our game, we don't really need these values from these get horizontal axis and get vertical axis functions. All we need to know is whether these functions return negative or positive values. So what I want to do is, when I create the adapter for the accelerometer, I would like to customize these initializer values. Now, obviously, we can customize these through different ways. We can add a constructor through which we can pass these values, but I've deliberately created this initialize as a virtual function that would give us a motivation for creating a class adapter. So this acceleradapter class that I've created earlier, we were composing the accelerometer here. We'll remove this and instead we will inherit from it. That's it. And then in the implementation, we can directly invoke these methods because they are inherited. That's it. And there still won't be any change in the output. Everything will work as before. But the difference is that instead of composing accelerometer, we are inheriting from it. Let's update the class diagram. Okay, something is wrong. So we will just delete this diagram and regenerate it. All right. So you can see acceleradapter now inherits from both input and accelerometer. One thing to note here is acceleradapter inherits from input because it needs its interface. So acceleradapter is inheriting interface from input. But when it inherits from accelerometer, it is inheriting its implementation and not its interface. Now if we build and run, there won't be any change in the output. So everything is same as before. But one thing I want to do is, I'm not really interested in such large negative and positive values. So when I create this axle adapter, I will override the initialize function. And in its implementation, I will return different initialization values. So I'll just return -1 and +1. What difference will this make? When these methods are invoked from axle adapter, let's go to the base class. When get horizontal axis or get vertical axis are invoked by the child class, these methods internally call initialize, and initialize is a virtual function. So these methods will invoke the initialize, which is overridden in the child class. And in the child class, we are returning different values. Now, if we build and run this, you will see the change. Now, this is possible because we have used class adapter. Class adapter inherits from the adaptee. And because we are using inheritance, we can override any functions that are inherited from the base class. So this is one advantage of using the class adapter. Another important thing is, when you create instance of the adapter, it is possible for the clients to see the methods of the base class. So you can see get vertical axis and get horizontal axis. And maybe you don't want to expose these functions. That is why there is an option when you inherit the adapter from the adaptee, you can use private inheritance. This way, the methods of the adaptee will not be exposed through the adapter. Now, we cannot access these methods here. So we cannot call get vertical axis or get horizontal axis. It's not possible because these now become private in the child class. So this is how we can implement the class adapter. A class adapter is useful when you want to create an adapter, but you would like to override some functionality of the adaptee. This will not be possible through object adapter. That's all about the implementation of the adapter design pattern. In the next lecture, we will see the different pros and cons of the class and object adapter. See you there.